mean Mr. MOSFET. MOSFET, X-bridge, toroidal pulse transformers, phase transformers, trifilar 16 turns, number 24, around little ferrite cores, feedback compensation section, separate little RF receiver to let me know when I'm in resonance. That's a 74HC14 inverting Hicks-Smith trigger with CMOS inputs, so it's very sensitive. So I've ganged all of the gates, all 6 gates together, and then the LED is running on the output of the last one. And there's the power in. The big red button and switch control the flow of current in the TinselKoil SSTC. That's the oscillator circuit. That's a pulse width modulation motor controller chip, and it's pulsing that X-bridge underneath the fans there, 4 little transistors, 2 PNP, 2 NPN power transistors, 2 tantalum caps driving the coil, and then those are of course inductively coupled into the gates of the MOSFET X-bridge, and then the output of that is running the primary of the air core resonator. It's 540 turns of number 30 Kynar covered wire wrap wire, and that's 2 stainless steel bowls, 4-inch diameter stainless steel bowls. Oh, the coil form is a PVC, I'm sorry, acrylic, clear acrylic tube with nothing inside. And then the toroid is just made out of aluminum duct, dryer duct, taped together, sitting on top of there. And then there is the power arc from the running of the coil. The buzzes that you hear in the background are from an AM radio behind me, tuned to 840 kilohertz. So the way I have it set up right now, it's resonating a little bit below 1 megahertz, and it's making a very nice power arc, as you can see. That gap is just about 1 inch at the bottom. And you can see the yellow electric flame. There. And oh, I can smell the ozone too. So here's my bamboo chopstick pointer. I'm going to put that up in there, and you can see how hot that is. The bamboo chopstick instantly bursts into flame, and those 2 little points where the arc hits the chopstick, those are hotter than the surface of the sun there. That's about as close to a point source as you can get when you're putting 6 or 8 amps average current into a point. So there's no wonder it gets hot. And bamboo fumes are toxic, so I'm going to turn the fan on. Sorry about the noise, but I got to get rid of this bamboo fume. Okay, so now I'm going to take a metal screwdriver right here, and we come around to the other side. So I've got this metal screwdriver, whoops, right there, and I'm going to just put it right in there, right into the arc, and you can see there that I'm drawing the arc right to my hand, and my body is part of the return circuit now. The resonance of the coil changes a little bit, which is why it's more difficult to draw the arc there. But there you go. So, is that showing up? Can you see that? Let me pan a little bit over here. way. Okay. So there you go. And I can't draw that directly into my finger because it would give me a really powerful RF burn. My fingertips are a painful RF burn. My fingertips are pretty much scarred from RF burns anyway, but I don't need any more. That arc is really hot, but I don't feel any electrical shock because the coil is running at 840 kilohertz, and even though my body is a major part of the ground return circuit, it's traveling on the surface of my skin, and so I don't feel it. Plus my nerves don't respond that fast. And it is a circuit. The bottom of the coil, the bottom of the secondary of the coil is behind there where you can see, and it is connected to that black wire to the bottom of the other side of the arc there. So there it's making essentially a short circuit. And when I put the screwdriver into the arc, my body forms part of the short circuit, and it's capacitively coupled to the ground, and the other ground return lead comes around. It's that yellow wire there, and it's plugged up into a spade lug there, which is connected to the mains ground. Okay. So that forms the ground return when I put my hand or the screwdriver in the circuit. Now what you're hearing there is the flame, the electric flame, is being blown out momentarily and rekindling. When it gets blown out, you see a nice corona discharge from the top of the electrode there. That's a disruptive discharge. And you can hear the radio in the background going wild. That sound, that buzzing sound. The hissing is from the coil. There, I've turned the radio off now, so you can tell and I'll turn the fan off. Okay, so now we have just the sound of the coil. Okay, shut her down. That's it. The TinselKoil SSTC. Thanks for watching.